What if humans could not only inherit genetic traits, but also inherit the experiences our ancestors had with environmental pollution, instantly adapting to toxic new worlds without waiting thousands of years for evolution? Imagine a future where exposure to smog, plastic chemicals, or radiation triggers epigenetic changes that do not just affect one individual, but leave a lasting imprint on their descendants' ability to survive similar challenges. This phenomenon, called epigenetic inheritance, means that instead of slowly evolving resistance over generations by random mutation and natural selection, humans might actively pass down survival blueprints tuned by their parents' environments. Now picture a bustling city inflicted by decades of chemical contamination and airborne microplastics, where future generations are born prepped with genes that better detoxify these poisons, modify metabolism, and repair cellular damage faster. On the surface, this sounds like a miracle, a natural buffering system allowing human populations not just to survive, but thrive in damaged ecosystems. Yet, deeper questions bubble to the surface. What happens when these epigenetic changes compromise other vital functions, or accidentally increase susceptibility to new diseases? Could such adaptations attract a hidden cost, like shifting energy integration in cells causing metabolic disorders or weakening immune balance most prized in today's interconnected world? Moreover, what if these environmentally induced epigenetic marks blur the lines between natural evolution and human-shaped adaptation, accelerating change in unforeseen directions with unpredictable outcomes? The environment would then not just sculpt our planet, but serve as a literal editor of our biology, editing line by line on an epigenetic manuscript passed from parent to child. But does this empower humanity to control its own biology through environmental choices, or trap future generations with the legacy of polluted pasts encoded in their molecular memory? It deepens the urgency around environmental stewardship, highlighting how pollutants might echo not only in habitats but transparently within us for generations to come. This could radically reshape public health, ethics, and policy as managing our environment translates directly into serious consideration of inherited biological resilience or vulnerability. At the same time, should we consider manipulating epigenetics to artificially train future bodies for anticipated climates and toxins, potentially redefining what it means to be human? What if our descendants owe not just their well-being, but their very identity, to the invisible memory written by ancestors within the chaotic symphony of changing ecologies? The concept challenges standard timelines of adaptation, calling on us to rethink survival as a shared legacy rather than isolated choice. So next time you breathe polluted air or handle a chemical, ask yourself, what invisible tags are you leaving on your genome, waiting quietly to rewrite your children's biology tomorrow? Epigenetics grows from a scientific revelation to a narrative about legacy, responsibility, and a uniquely human battle to coexist with a planet we now fundamentally shape. Tell us your thoughts in the comments. If you could toggle an inherited epigenetic switch that prepared you for the world's future challenges, would you choose to live in that engineered destiny?